If you look at the literature on the subject, there are many books about the differences between men and women. Evolution is not something that most of them even touch on, but it's very important. First of all, it's just worth thinking, why bother to have two sexes? Wouldn't it? It would be less fun to have just one, but it's a way of generating more variety. And evolution cares about variety. And just let me tell you, evolution only cares about reproduction. It doesn't give a damn about anything else. It only cares how reproductive you are.
I'm going to show you two images of a penguin. Can you tell me the difference? If you couldn't figure it out, well, one is a Chad penguin with friends, and the other is a sad, lonely penguin with no life and horrible posture. Okay, well, not actually. The actual difference is quite ubiquitous. One is male and one is female, but you couldn't tell that just by looking, could you? I mean, I would be surprised if you could, and I mean, not even experts can tell just by looking. They perform DNA tests on them in order to, tell with certainty. But in terms of humans, it's glaringly obvious the difference between biological males and biological females. Males with their broad shoulders and taller stature compared to females with their smaller waists and rounded facial structure. I mean, what's the point of these differences? Well, I'll show you that and even more in this video, where we are going to be digging into nature's most interesting cases of sexual dimorphism. Before we even dive into these cases, we have to know a little bit of background knowledge, such as what is sexual dimorphism? Well, simply, it's the difference of characteristics among members of the same species, typically attributed to gender. But more importantly, why does this happen? It all stems from evolution. Evolution supplies these changes that are advantageous, and they continue to be passed on to the next generation and thereon after. In humans, for example, because we love talking about ourselves, we give live birth. A mother organism must not only attract a mate, but also carry to term any subsequent children that come from that attraction. That's why women have wider hips, in order to make sure the child can leave its initial home, or why their mammary glands are noticeably larger compared to their male counterparts. They're built like this in order to provide nutrition needed in order to sustain any offspring. Males as well have stronger builds in order to compete and provide for partners. That way, they can give them the strength to carry that child to term. Live births are an investment. A mother has to provide more nutrients and care for herself at an unprecedented level in order to make sure her little gamete forms into a big, strong organism. If not, well, then she runs the risk of genetically fading into non-existence. Little side tangent, but that's why common features that you may find attractive are, attractive. Maybe you're attracted to a woman's gluteus maximus because of her wide birth canal, which sounds incredibly weird as I say it, but I digress. Same way that you may be attracted to a man that is tall and rugged due to the inherent perception that he knows how to provide. In many egg-laying species, you won't notice many types of dimorphism in sexual terms, but instead, you notice it physically, and these have many different reasons why they occur. They fill a niche. But what is a niche? A niche is, in layman terms, the role that an organism plays within its environment. There are two different types of niches, fundamental niche and a realized niche. And, just for shits and giggles, I'm going to put a niche counter in the corner of the screen to see how many times I say the word. Say we have a lion and a cougar. The lions can live anywhere in the environment. It can live here, it can live there, or anywhere it so pleases. The cougar can only live in this upper area of the environment for whatever reason. Maybe maybe its food source is plentiful over there, or it has an unattended side piece. In nature, instead of constantly competing with each other because it costs more energy that could be, used instead to maybe entertain the aforementioned side piece or hunt for food, we notice that lions typically stay in the lower area and the cougars stay in the upper area. But why is this? Well, this is an example of the phenomenon known as niche partitioning. The fundamental niche is any theoretical area an animal can have it. In our example, the fundamental niche of the lion would be the entirety of the environment. The realized niche is the actual use of the resources that the animals portray in nature, such as the lion only using the lower level and the cougar staying on the top. This further pushes evolution since these animals are competing in the same area but with different resources, and over time they will become better adapted to hunt for these resources. Let's relate this back to dimorphism, and let's use an actual example. These beautiful birds are known as the Huia, typically native to New Zealand. Sadly, these birds have been extinct for exactly 100 years as of the writing of this video. The reason I chose this bird was to not only provide a glimpse into a bird long forgotten by history, but also due to the fact that the characteristics that separate their genders are quite prominent. The females of the Huia species sport a long, curved beak compared to their male companions that possess a wider, shorter beak. The fundamental niche of this species of birds are bugs within wood, specifically larvae living within it. Within the entirety of the tree, these birds could hunt, but we have a problem. With egg-laying species, since the mother isn't debilitated by changing physiology, it takes on a providing role such as a male would in live birth relationships. The problem that arises is that these two individuals of the same species, while providing for the same offspring, compete with each other. This is called intraspecific competition. Remember what I said earlier about competition? Competition is too energy demanding to be viable for a long period of time. This is why eventually there must be a winner, but when there are competing individuals of the same species, it becomes a bit more complicated. So it's easier in the long term for these species to split paths in their characteristics in order to reduce the competition between themselves. This in turn influences the realized niches of these species' genders. As we recall, the fundamental niche of the Huia can be the entirety of the tree. I'm not completely sure, but for simplicity's sake, let's say the common answer of the Huia started with a short white beak. With this beak, the Huia are able to dig into the tree and rip away the outer layers of the wood to expose larvae residing inside. If there are 10 larvae in the accessible area by the primitive Huia, if a pair were to hunt for these, they would only be on average able to collect 5 larvae per bird. While in theory, the bird could prey on the larvae of the entirety of the tree, it could only access the layers that the beak would allow. Now, later on in the evolutionary timeline, the females have gained their new beak, which increases the area of the realized niche. While technically the males and females can both extract larvae from the outer layers of the tree, now the females can dig into deep burrows of the tree to extract even more. Due to niche partitioning, the male now specializes in the outer layers and the female focuses on the inner layers inaccessible to the male. Now, instead of the previously available 10 worms in the outer layer, the female can now access even more worms, let's just say 10 more, for a total of 20 worms, which increases the average between the birds and the output that they are able to produce. I know that was a lot of information, but it is absolutely necessary to understand this interesting product of nature, diverging members of the same species. With this knowledge, we can now explore a more extreme case and possibly provide an explanation as to why they spent their evolution points into these traits. This next animal may be known as one of the ugliest mugs to exist in the ocean, the terror of the deep sea, a deep sea siren if you will, the anglerfish. I'm sure many of you are familiar with it from the little indie movie called Finding Nemo. You know, it's a little small indie film. But we could see in the movie that compared to Marlin and Dory, that the anglerfish is an absolute behemoth. Well, due to the extreme sexual dimorphism, we can actually tell that the anglerfish that almost cut our fishy hero's journey short was actually a girl. There are over 200 species of known anglerfish, and 160 of these mate in a very unusual way, living 1,000 meters beneath the depths or 3,280 feet in, freedom units. It would be quite hard to see who the hell you want to boink with. So how do they do it? Anglerfish perform what is called sexual parasitism. And you'll understand what I mean when I show you the male anglerfish. And it doesn't look like this or, even that thing. It looks like this. This tiny dude is 60 times smaller than the females of the species. For reference, the average human male is about 175 centimeters or 5 foot 9 inches. The female anglerfish, in comparison, is the length of an entire football field at about 10,500 centimeters or 345 feet. So yeah, it's pretty big. So let's look into the male's development. Aside from the size difference that the males possess, they also have incredibly well-developed eyes and big nostrils, but also at the cost of no digestive system. The reason for such attributes is due to the conditions that these organisms are under. Little to no light is commonplace at the depth these deep sea monsters call home, so in order for males to find a female to mate with, they must follow a pheromone trail excreted by the females and follow. Once near, they use their eyes to assure themselves that this is truly a member of their species by recognizing the characteristic glowing rod that the females possess. A mistake in this will prove truly fatal for the male. Once a male finds a female, they latch themselves onto the female specimen with sharp teeth. Once they attach, they release an enzyme that breaks down the skin barrier between them, and the male fuses with the female, making himself a part of the female's circulatory system, where it receives sustenance. In return, the male provides sperm to the female. Sounds pretty toxic if you ask me. These bums have no way to fend for themselves and leech off their partner in order to survive. Yikes. In all seriousness, this form of mating is why the practice is called sexual parasitism. The male acts as a parasite, but if you want to be technical, it's more mutualism than anything, but what do I know? An interesting fact is that usually not just one male attaches itself to a female, but up to 8 have been attached to one specimen. Their job isn't done as soon as they attach. They have to compete to get their sperm to the eggs that the female lays. There could be a number of reasons why these members deviated so drastically. There's 2 reasons that I truly believe in, personally. Reason number 1, competition. If both members of the species were to grow to relatively the same size as the other, they would fight for the same resources in order to maintain their own longevity. In the aphotic zone, resources are scarce. Possibly the males involved in order to give the mother a more likely chance to survive, to lay the eggs and allow her a greater pool of resources to choose from, and at a significantly smaller size, the males would require a fraction of what the females consume in order to maintain itself. The second reason could be parental needs. Most species of fish are not great parents. They just kind of leave their eggs there and let them be and hope they don't get eaten. There isn't a need for both of the parents to be extremely present. What there is a need for is survival, and the survival of the female specimen is the priority over the male one. Let's look at peacocks, for example. A typical male peacock only lives for 10 months compared to the years that females live. This is obviously due to the fact that the males completely stand out in their environment. Brightly colored feathers doesn't necessarily mask with the glowing flora of nature, but that doesn't matter in the long term. The male's goal isn't survival, it's mating, and the bolsterous nature of its feathers make it more likely to mate with multiple females and pass on its genes. The survival of the mother is more important, again due to the fact that they are the ones that physically make the eggs and care for it. This principle applied to the anglerfish makes sense. The female anglerfish is tasked with surviving in order to produce the eggs required, and the more dispensable males are tasked with finding a female to lend their sperm to in order to assure the continuation of the species. That explains why multiple males attach themselves to only one female. In the event that a male doesn't make it to sexual maturity, the female has other sources of gametes to rely on. Again, this is just a theory, a fish theory one can say, not a tried and true explanation as to why the anglerfish has chosen such a weird form of procreation. Nature is amazing. You look outside and everything you see, from the squirrels to the grass, has endured thousands if not millions of years of trial and error to endure the test of time. While the trials may lead to interesting results, such as our anglerfish buddies, they have also produced the beauty that we get the privilege of witnessing every single day of our lives. I hope you enjoyed my video, and if you did, make sure to like, subscribe, comment, or do whatever your merry heart desires. I hope you enjoyed, and have a wonderful day, night, or whenever you're watching this. You matter, and thank you.